Welcome back. UVM is one of 5 schools working with NASA to develop its next generation of technology. Kat Villanzoni caught up with a team of engineering students working to solve a tricky problem. And Kat, what are they working on?
Well, Julie, it's called the XHAVE Project, and its goal is to make the technology that we need to study space lighter and easier to transport so that someday we can send it deeper into our solar system. What is this?
So this is kind of a model of our airlock. The real airlock is going to be actually 9 feet in diameter and about 12 feet long.
An airlock is the compartment that allows astronauts to move between the inside of a space station and the vacuum of space. They're an essential part of space exploration. And Joseph Mazer and his team of fellow engineering students have spent the last year working with NASA to develop an inflatable airlock. Their design uses air beams, fabric tubes that, when air is blown through them at high speed, act like a solid structure.
That essentially holds the structure, rigid, so the astronauts can actually create the inner chamber to be void of air and actually exit the station or ship that they might be in.
So basically, you're trying to get astronauts to be able to transition from 2 radically different environments.
Exactly.
Current airlocks are metal, heavy, and very expensive.
On the space shuttle, it was $10,000 per pound to get mass in orbit. So anytime you can replace a heavy, massive metallic airlock with a lighter version, you're saving money, right?
Right.
So, and it lets you use that mass budget for something else.
Russ Smith with NASA says it's an ambitious project for these students. And right now, the concept of an inflatable airlock is in the very early stages. The UVM model was built with materials you'd find in a hardware store: 4 leaf blowers, a winch, and flexible ductwork. The actual materials are too expensive, and we don't have zero gravity on Earth, so they had to improvise. The real materials tests will be up to future teams down the line.
But how quick did it open when it broke?
Right now, the focus is on the concept. Air beams have been around for a while, but they're usually unfolded and then inflated. This team is using their model to test whether they can inflate while they're still folded and still be safe.
When you kind of compress fabrics, they fold and twist, and you won't be able to get air through them, or you create pockets of high pressure, and you could have blowouts and things like that.
A year's worth of work and hundreds of hours have paid off for this team. This week, they were able to present this model to NASA for the first time.
Working with college students is always great because they're always kind of out of the box.
Mazer says doing a project like this as an undergrad is a dream come true.
They don't try to dumb anything down for you. They treat you just like, one of their colleagues. You really felt like you're, a part of their team. That's a great feeling when you're growing up as a kid wanting to be an engineer. Like NASA is like the end-all be-all of, what that is.
This team, of course, is not done yet. They actually have a few exciting events coming up. One of them is this summer in Boston. They're going to be presenting at the 4th Annual International Space Station Conference. And they're also going to be featured in an upcoming article in Smithsonian Magazine.
Wow.
I know, right? It's like a dream come true for me, so I can't imagine what they're feeling like.
I can't imagine either. We have so many impressive students, and what a neat way to understand science. So thank you so much, Kat.